In this lesson, I'm going to redo an algebraic proof using a different approach. I noticed that on the exam 1, a lot of you confused with when is the largest addition property equality versus substitution. So I'm going to redo this example 1 here from lesson 5 and then using a different approach where it require me to use substitution. And here it goes. So last time we did this lesson in lesson 5, we did it this way. We say, well, to solve this equation, I could just add, for example, first step, I subtract 3 to both sides. So from step 1 to 2, I say subtraction property of equality. That's 15 minus 3 give me 12. 3 cancels out left hand side, subtract 3 is gone. Now next step, I say, well, I could just divide both sides by 4 and to get the next step. So the left hand side divided by 4, right hand side divided by 4, then I have 3 left. So therefore step 3 from 2 to 3 here as a division property equality. Well, next step I did was add 1 to both sides. So basically I add 1, I add 1 to both sides. Well, a negative 1 and 1 give me just 2x, 3 plus 1 give me 4. Since I'm adding 1 to both sides, I say addition property equality. So notice that I didn't write the division here here I just did in hand and keep the solution only. So now let's do a different approach. I'm going to erase this and redo it. Okay. So again, it's the same question. I'm just going to show a few extra steps. Okay. Well, let's recall what substitution is. So substitution basically saying here said that if I have expression A equal to B, then A can replace B in any equation. So if they equal the same thing, I can just replace it. So let's keep it in mind and do it. Where addition property equality tells me that I could add a number to both sides. Let's say, for example, over here, A equal to B, I can add C to both sides of the equation, then if still hold true. Subtraction property, I can subtract C to both sides of the equation where it still hold true. So let's keep these two things in mind. So let's do this. Okay. So for step 1, I'm going to copy down what is here. So step 1 is still the same. So I have 4 times 2x minus 1 plus 3 is equal to 15. Number 1 is given to me. Okay. Now I said like before, I said, well, the next thing I could do is I could just subtract 3 to both sides. So I'm going to write subtract 3 to both sides. So we write step 2 as 4 times 2x minus 1 plus 3. I'm going to subtract 3. Okay. And on the right hand side, I subtract 3. So I have 15 minus 3. So number 2 over here, that's my step 2. Notice that from step 1 to step 2, I subtracted 3 to both sides here. So I call subtraction property equality. Property of equality. Well, in algebra, the next step we said we call simplify, right? We said that, well, 3 minus 3 here is 0. Let me highlight it. You know, so 0 is equal to 3 minus 3. 15 minus 3 is going to give me 12. So I'm going to rewrite the previous expression using a simpler expression. I'm rewriting it. So 4 times 2x minus 1 is equal to 12. Notice that from step 2 to 3, I'm rewriting the same thing. I say, well, 15 minus 3 give me 12. I replace it with 12. 3 minus 3 is 0. I replace the 0, which I don't have to write it. I replace the same thing with a different expression. So here I have 12 is equal to 15 minus 3. On the left-hand side, 0 equals 3 times 3. I'm replacing the equivalent expression using a simpler one here. So this step here is called substitution. Oh, I mean substitution, that's not subtraction. And just substitution. I'm basically substituting, for example, here I have 12 is equal to 15 minus 3. I'm replacing with an equivalent expression here. Okay. So next step, Number 4. Well, what can I do? I see that some of you using a different approach, using the distributive property. A basic distributive property tells me that I can distribute it inside. So you're not sure, you can look it up again here. So distributive property tells me if I have A equal to B, the A gonna distribute inside, right? This direction. It's a distributive property. So here I'm gonna use a distributive property and say, well, this is AX minus 4 is equal to 12. I use the distributive property here. Oh, let me write a step correctly. This is step 3, this is 4. So this is distributive property equality. Again, you can just look at the name right here called distributive property. And in terms of equality here. So let me write it. Oh. Distributive property of equality. Okay, now next step, well, I could just add 4 to both sides, so let me write it. So number 5, I could say, well, AX minus 4, I'm going to add 4, is equal to 12 plus 4. I'm adding a number to both sides of the equation. So addition property of equality. Okay. Number 5, number 6. Now next thing what I do is I'm replace the 12 minus 4 with 2 plus 4 is 16, and replace this with 0. Adding 0, don't have to write it, so I just rewrite this. AX is equal to 16. Okay, so number 6, I'm replacing equivalent expression. A 16 is equal to 12 plus 4, so this is called substitution. Okay, and next step, I could divide both sides by A, which is what we usually solve. So number 7, I could say, oh, let me do it consistent with color here. So I say AX divided by A, 16, I divide both sides by A. Okay, so since I do something to both sides of the equation, this division property equality. Okay, next step, like before, I'm rewriting a second expression in a simpler form. So this is x equal to 2. Number A, I say, well, I just rewriting using the same expression, equal expression here. So substitution. That's it, we're done. I did this is the same way. It's a different proof. It's the same proof, but using a different approach here, where I utilize it adding to both sides and substitution here. Before, notice I didn't use substitution before. We just say, oh, we just divide it and get the answer only. So this is totally a good proof, and I'm just adding extra steps here. Thank you for watching the video. I'll see you next time.